Welcome students. Today we are going to learn unit number 1 of metrology and quality control subject. The title is measurement standards and design of gauges. So these are the contents of unit 1. Today we are going to cover the introduction part. In introduction part we are going to cover principles of engineering metrology and measurement standards. Let us start with principles of engineering metrology. What is meant by metrology? This is what is the very first question which comes to our mind. Metrology is a Greek word. It is made of two words, metro plus logy. Here the metro means to measure and logy means science. Metrology is defined as the science of measurement. So it deals with establishment, reproduction, conservation and transfer of units of measurements and their standards. Metrology consists of comprehensive study of different measuring instruments for defining precision, accuracy, possible sources of errors and methods for elimination of errors to improve the accuracy. Generally, raw material received by a manufacturing industry from an external source, that is supplier, is processed by number of operations carried out on various machines to give a final finished product, which can be sold to the customers in market. During the entire process of transformation of raw material into finished product, inspection is carried out for inspecting the product being processed at various stages of manufacturing. So this process is done with the help of measuring instruments and gauges. Basically, metrology is categorized in following three categories. First one is scientific metrology. It deals with the establishment and development of measurement standards along with their maintenance. Second is industrial metrology. It has to ensure the adequate functioning of measuring instruments used in industry as well as in production and testing processes. Third category is legal metrology. Legal metrology deals with units of measurements, methods of measurement, measuring instruments. These are to be strictly followed during the act of measurement. Legal metrology is concerned to find out whether the conditions, that is mandatory conditions and legal bindings which are specified on above points, are fulfilled or not. Now we will see different measurement standards. So first of all, what is meant by standard? Definition of standard. A standard is defined as something that is set up and established by an authority as a rule of measure of quantity, weight, extent, value or quality. Rule which is universally accepted, that we are going to call it as a standard. Hence, a standard is defined as a physical or material presence of a unit. The role of standard is to support the system which makes measurements possible throughout the world. For example, imperial yard and imperial standard meter have been used as standards which are widely used all over the world. But since 1960, the wavelength of light has been adopted as the standard of measurement. Here, imperial standard yard and meter, these are the material standards, whereas wavelength of light is a wavelength standard. Line standard. What is line standard? The length is expressed as the distance between two lines or points. For example, international meter standard, steel rule, inside outside calipers, where the unit of length is measured as yard or meter. Line standards are quick and easy to use, but they are not accurate. Accuracy of measurement depends upon the skill of operator performing the measurements, which varies from person to person. In addition to human error, calibration errors also leads to inaccuracy. During calibration of scale, very small deviations in graduations or divisions engraved on the scale leads to highly inaccurate measurements. Now see here, examples of line standard. First example is steel rule. Second example is international standard meter. So I have shown here the figures of steel rule and international standard meter, which are the examples of line standards. Now next standard type is end standard. End standard, where length is expressed as the distance between two flat parallel surfaces. End standards are very commonly used in laboratories and engineering workshops for all the practical purposes. For example, slip gauges, ends of micrometer anvils, end bars or length bars, jaws of vernier caliper. These are the best examples of end standards. End standards can be made to a very high degree of accuracy. A modern end standard consists of hardened block or bar of steel. Their end surfaces are made truly flat and parallel by the process of lapping or superfinishing. Since primary standards are line standards, end standards must be calibrated from line standards. Now these are the examples of end standards: micrometer and slip gauges. I have shown here the examples of end standards. The next type is wavelength standard. What is wavelength standard? Wavelength of monochromatic light is used to measure the length. So that type of standard is called as wavelength standard. Line standards and end standards are material, that is physical standards, which are subjected to the destruction and their dimensions may vary with time. To overcome the above difficulties, wavelength of light is introduced as standard of measurement. It is highly accurate and does not depend on any physical standard. With monochromatic light, we have the advantage of constant wavelength. Wavelength standards work on the principle based on the phenomenon of interference of light waves. This interferometry technique enables the size of slip gauges and end bars to be determined directly in terms of the wavelength of light instead of meters. Since wavelength does not have physical form, therefore it is not needed to be preserved like material standards. Therefore, wavelength standard is called as reproducible standard of length. Error in reproducibility is very small, that is 1 part in 100 millions. Therefore, this error can be neglected. Krypton 86 is the most suitable source of radiations of constant wavelength. Due to its high degree of accuracy, it is accepted as international wavelength standard. So this is all about wavelength standard. So let us stop here today. Thank you.